we've got another POE hat.
We have, yes.
How many POE hats is this now?
I think this is the third one, isn't it?
Yes. So we had POE, and then we had POE Plus, and then we have this new thing which is not called POE Plus Plus. It's called POE Plus for Raspberry Pi 5.
Yes,
yeah, okay,
because
good.
POE++ is a higher power standard.
It's another thing. Okay, fine. So this is a to be clear, this is a POE Plus. So the standard it implements is POE Plus, which is the 25-ish watt standard, and it's intended for use with Raspberry Pi 5. Now, why did we need to do another POE hat?
Well, Pi 5 introduces a lot of new things, and one of the things to make board space in the right area was the POE connector, the little 4-pin connector, got moved to the other edge of the board.
This is as part of James's plan to put the Ethernet jack in all possible positions on different versions of Raspberry Pi.
I can't say if that's James's plan or not, but that appears to be the starting point.
So we've had almost all, we've had of the sort of 4 combinations now of mag jack at the top and bottom and POE connector at the top and bottom. We've had three. We've had across 3B plus 4 and 5. We've had 3 of the 4 possible options.
We have.
Right. So there's a simple.
He's not going to go to the other edge of the board yet. So
there's a simple mechanical reason.
Yes.
Which is that 4-pin connector. What does the 4-pin connector do?
That takes the volts from the POE from your Ethernet cable. Mm-hmm. So it's around 48 volts and brings it out to those pins there. Then for the POE hat to take that and convert it to the 5 volts. Right.
So we have a POE capable mag jack.
Yes.
What does that mean? That's extra taps on the windings, is it?
That is indeed extra taps on the primary windings. So this is non-isolated volts direct from the cable through the transformer. Well, not through the transformer. It's just tap on the transformer, and then those 4 pins go up to the POE hat, which then gives us the isolation required to generate then the 5 volts to power the Pi 5.
So it provides isolation. It provides voltage conversion regulation, and it feeds 5 volts back into the GPIO connector, the top left in the top left-hand corner.
And there's one other thing it does is all the POE negotiation as well. So it will negotiate with the switch.
Okay, so you have to advertise, so you have a POE capable switch or a mid-span injector, and you have to advertise to that you are POE capable before it will give you the volts.
Yes, and then
in theory,
which power range you want as well.
It's not a injector that just gives you some volts.
Yes. But there are also the 2 power ranges, the 13 watt and the 25 watt power range. Right. So then the Pi can detect which power range is available.
How does that signalling work?
On the Ethernet cable,
yes.
It does it by, first of all, it looks for some capacitance on the cable to know that there is something there. And then
this is the switch.
With the switch, right. Yes. And then it applies a voltage to the cable, and to then try and detect a resistor of a particular value. Right. And if it can detect that, then it knows which power range available. There are more advanced methods for the POE++ that we were referring to, but we don't do that, so no need to describe how all that magic works.
And there are POE modes where you put the power on the spare, the pairs that are spare in some standards.
Yes.
And then there are modes where you put it on the signal pairs, and you have to support both of those.
Yes. Yeah. So that's why there are 4 pins. So each pair ends up with a pin.
Right.
And because of crossover cables, you end up with each pin could be positive or negative. Right. Officially, it should only be in pairs, but if things go wrong, it could be anywhere. Right. So there's a very fancy bridge rectifier at the front. It's an active bridge we use.
Yeah, so it's not just 4 diodes in a little circle there.
Well, it would be 8 diodes because you've got 4 wires coming in.
Yes, indeed.
So it would be 8 diodes. Yeah. And so we've got effectively 8
diodes. And what would
be
the problem with them being diodes, actual diodes?
It's just power drop. And so you just, a diode, because you've got to withstand at about 100 volts, worst case peak energy. If there is unplug events and things, overshoots and undershoots. So the diodes have got to be quite chunky diodes. And so you end up with 0.7 to 1 volt drop across each of the diodes. And you've got 2 of those, and you're taking over half an amp. Yeah. That's power. Right. And power is heat. And so what we have is an active bridge which is made up of little FETs in there, and that then makes they have RDS on, so that's I squared R losses at that point, but the
RDS on is tiny.
It's tiny compared to
milliohms.
So we've dropped, it becomes 90% efficient instead of a lot less percent efficient.
Cool. Okay, so that's POE hats, what they do. Are there any other? So let's talk a little bit about the evolution from POE hat to POE plus hat to POE plus hat for Raspberry Pi 5. What were the technologies that were introduced in each of these? Because this isn't just a mechanical thing, right?
Yeah.
There's also some new technology in this design, and there was some new technology in the POE plus hat originally.
Yes.
So what's kind of been introduced at each stage?
So the first POE hat was only a 13-watt product, and that had a much more conventional transformer on there.
So when I think about transformers, I think about a sort of a ferrite core with some windings, some wire wrapped around it by a machine, then clamped together, and then some wires coming out.
Yep, and you can see that on the original one. And that was what's known as a flyback converter. And then we moved on the next one, the POE plus hat. We did two things. We changed to a forward converter, because forward converters are typically more efficient when you want the top end of the power range.
And that's very much what POE plus hat was engineered for, right? POE
Yes.
plus hat is engineered to give you another kind of double the peak power, and to be most efficient at the top end of that range.
Indeed so. So at just below 25 watts, or the 20 to 20 odd watts range, it's much more efficient than a flyback converter is. But we also changed the transformer technology. So we went from having a wire around the ferrite to using a PCB, which has turns in tracks on the PCB with a ferrite clamped over it. And that was a separate little board, and you can see that gets soldered in.
I remember the first time I saw one of those. I mean, it's such a beautiful little space-age solid-state bit of stuff, right?
Yes.
It really does look beautiful.
So the winding density is less because you've got to have the PCB substrate, but you get other advantages. So your skin effect, which is an effect when you have high frequencies, virtually disappears onto the planar because you've got a lot of air, you've got a lot of surface area for your copper, and you can just thicken up the copper on the PCB. So if you need,
how many layers of PCB is that?
I can't remember.
It's a lot,
it's probably
though,
8 to 10 layers PCB.
Yeah.
And what we've done now for the latest one is taken that, instead of having a separate PCB, we've now got one PCB, which then has the ferrite clamped on. And so that one PCB has the 40-pin connector on it. It has the 4-pin power connector, and then also has the turns built into.
So we built, rather than buying a transformer from somebody else, we've actually built our own transformer on our own PCB, and then we just put a ferrite around it.
And because of the various bits of optimizations we've been able to do, we've gone back to a flyback converter.
Right.
But we've been able to keep a very good power efficiency on there. And that's allowed us to reduce the board area of the amount of components on the board. So it's now L-shaped.
Yeah. So this thing is I think there have been a lot of debates as to whether it's a compliant, is it a compliant hat? Is there a requirement that a hat has PCB in all of the places that a hat can have PCB? But yeah, so this thing it's L-shaped. Now, what does that let us do?
Well, that now lets us. Previous POE hats had a fan on board,
and that wasn't for cooling the POE hat, right?
No, that was for cooling the SoC.
Right. So it was a sort of kind of a bonus feature of the POE hat, was it also had a thermal solution for the CPU.
Yes, and so it was. So it had this big hole in the middle of the PCB. So there was a lot of wastage of the PCB because it just gets thrown away from the middle.
We're already almost an L-shaped PCB.
Yes, but we needed the area. Yeah. If you have a look at it, it's quite a dense board. But because we've been able to simplify some of the electronics now and integrate things more, especially around the area of the transformer, we've got this L-shaped thing. Board, and that then allows us to put it in the new Pi 5 case as well.
Yeah, which itself has a fan.
And that has the fan,
right.
Yes. And so there's been a lot of 3D work to make sure it all fits, and it's all very compact, but you can now have a case with a built-in fan and a POE solution, all nicely together.
That's very neat. Good. And how much more efficient is it than the previous design? Is it more efficient than the POE Plus design, or is it?
It's more efficient at the lower
Right.
at the lower power levels.
So we now have efficiency across the power consumption range rather than concentrating that efficiency up at the top.
Yes. So with Pi 5 being able to go more into sleep modes and things like that, and that's then is better for your green credentials because you're not then wasting so much power in the conversion. And that's where a flyback converter is more efficient than the forward converter.
Right. So we've gone back to a flyback converter, gets us the low end efficiency. We've done clever stuff to mitigate the nominal inefficiency of the flyback converter at high load, and then you get nice high efficiency all the way across the range. Excellent.
Yeah.
Well, that's good news.
Excellent. Yeah, I hope so.
Yes. I'm looking forward to having a play with it.
So am I.